Okay, good evening, all. Welcome to Infosys Coding Round Training, Day 9. Hope you are all doing well. So, preparing for the next session exam that is on 25th. So, learn all the techniques, practice more problems on the topics which I mentioned in the first video. Still, if you have any doubts regarding the number of questions and what are the topics to be covered. Okay, so what are the difficulty levels of the questions? Just you can watch the first video, day 1 video. So today we will discuss an important dynamic programming technique called tabulation technique. Okay, so let me share the screen. So we said that in dynamic programming approach, there are two types of approaches are there. One is called as a top-down approach and the other one is called as a bottom-up approach. In yesterday's day 8 video, we discussed this. Okay, so top-down approach uses a technique called as a memoization, and whereas bottom-up approach uses a technique called as a tabulation. Okay, so in yesterday's video, we discussed about this memoization technique and we implemented this memoization technique to solve a problem. Okay, so if you have missed that video, so please go back to my channel and watch day 8 video, then come back to this video. Okay, so in today's session, we will learn the tabulation technique, which is bottom up approach in dynamic programming. So tabulation is called as a bottom-up approach technique in dynamic programming. Okay, so it is a common method used in a DP to solve a problem iteratively using a table. Okay, so we use a table for solving the problem. That's why it is called a tabulation technique. So generally the table is represented as an array. So it starts by solving the smallest subproblems. Okay, so first the problem is divided into smallest subproblems and it finds the solution to the smallest subproblem first and stores their solutions in the table called this table array. Okay, so that smallest subproblem solutions will be stored in the array. This is how it starts solving the big problem. Okay, so then iteratively it computes the solutions for larger problems by combining the solutions of smallest subproblems, then it tries to find the solution to the larger subproblem until it goes on. Okay, so bottom from bottom it goes on computing the solutions for larger problems. Okay, so like this it goes on from bottom to top until it finds the solution for the final problem. This is the approach followed in a tabulation technique. So the main advantage of tabulation is its ability to avoid recursion. Okay, so here no need of using a recursion. Okay, so we said that even memoization uses recursion. Some part of recursion will be used in a memoization. Okay, so memoization is nothing but recursion plus caching. Okay, so even this recursion again involves a function called overhead. Okay, so to avoid this function called overhead, avoid this recursion. Okay, so we use this tabulation technique. Okay, and explicitly compute and store the solutions to the subproblems by using this tabulation. That is the main advantage of a tabulation technique. Okay, so this leads to better time complexity compared to other techniques like memoization even. Okay, so which can suffer from overhead of the function calls. So there is no recursion involved in this tabulation technique. Okay, just by using iteration and using a table, we can solve the problem. So one such problem which requires dynamic programming approach. Okay, so the very famous problem in lead code is calculating the longest increasing subsequence. Okay, so the question is like this: given an integer array nums, okay, so return the length of the longest strictly increasing subsequence. Okay, so from that array, you need to calculate the longest increasing subsequence. Okay, so that subsequence length you need to find out. There will be only one such a longest increasing subsequence in the array, and what is the length of that subsequence? Okay, that sub array. That means how many elements are forming that subsequence. Okay, so that length of that subsequence you need to calculate, and that length value you should return. Okay, so here the meaning of subsequence is also given. A subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. Okay, so you should not change the order of the elements. In the same order, they should appear like the original array. Okay, so by deleting some elements or no elements, even the entire array can be a subsequence sometimes. So example given here. So 3, 6, 2, 7. If this is the given array, okay. So it is a subsequence for this entire. This is the array actually. Okay. So 3, 6, 2, 7. Okay. So see here 3, 6. Okay. So 2, 7. It can be either this two or this two. 2, 7. In the same order, the elements should appear here. Okay. So then that is called a subsequence. If you write this sequence in this order 2, 3, 6, 7, no, this is not called a subsequence for this given array. Okay, so in original array, how the elements are appearing in the same order, they should appear in the subsequence also. Then only it is called a subarray or a subsequence. Example given here, first example, this is nums array given here. So output should be 4. So explanation is also given. The longest increasing subsequence is 2, 3, 7, 1, 10. Okay, so just see here. It is 2, 3, 7 and 1 not a 1. Okay, so that means the elements are increasing in the order. Okay, so they are arranged in increasing order in this. They may not be continuous, okay, but these elements form an increasing subsequence. Okay, so then the number of elements present in this are 4, so that's why the answer is 4. Okay, similarly here there is a another array 0 1 0 3 2 3. Okay, so what is the best subsequence we can obtain here? Okay, so 0 1. Okay, so then if you include 3, you cannot include any other. Okay, so then we include this 2 here, then 3 here. Okay, so this is the increasing subsequence. Elements are in the increasing order, so the number of elements present in it are 4. Okay, so this you need to find out, this subsequence you need to find out. Okay, so this kind of subsequence you need to find out, and no need to print this subsequence. What you require is you need to print the length of this subsequence. How many elements are there in this subsequence you need to print here. Got it? Okay, so first let us try to develop the logic for this. Given example array, okay, nums array. Okay, so we will try to find out such a subsequence. Okay. So we'll take a simple example here. We'll take a nums array like 1, 2, something like 4, 3. Assume I'm taking a small array here 1, 2, 4, 3. Got it? So now you try to find out a subsequence. Now each subsequence forms 1, 2, 4, 3. Each element forms a subsequence of length 1. Yes or no? This subsequence length will be 1 here. Okay. So because each element forms a subsequence there. So what you need to do is you need to develop the logic by using a dynamic programming approach. Okay, so we use DP approach for solving this problem. Okay, so how we can use a DP approach? What we do is we use an array which stores. Okay, so we use an array which stores the count of each subsequence. That means length of the each subsequence at index I. Okay, so this is index 0, index 1, index 2, index 3 here. Okay, so if an array is ending at index 0, at index 1, at index 2, and at index 3, okay, so what is the length of a increasing subsequence? Okay, so that we will store in this array here. Okay, this table. Okay, so let us call this as a LIS, length of increasing sequence or subsequence. And initially we said we'll store all ones in this because each element forms a sub array with length 1. Okay, so that is why we store all ones in this table called as a LIS table. Okay, so then how we need to do here? That means first we take the first element here. We'll take the first element. Okay, so then we'll check whether this first element with the remaining elements, what are the remaining elements? 2, 4, and 3. Okay, so with the remaining elements, if they are forming an increasing subsequence, then we count the length of that subsequence and we'll store that uh, at this array called as a LIS array. Okay, so initially all four elements form a subsequence with length 1. That is what we stored here. Okay, so then I am taking this first element 1. Okay, so I will check whether the first element 1 and first element of remaining elements. Okay, so this 1 and 2, this 1 and 2, whether they form an increasing subsequence or not, that we will check here. Okay, so 1, 2, are they forming a increasing subsequence? Yes, they are forming an increasing subsequence. Okay, so that means at index uh, element 1. Okay, so 0 and 1. Okay, so these two are forming a increasing subsequent whose length is equal to 2 here, whose length is equal to 2 here. Okay, so then what I do is I increment this value here. That means this 2 indicates that okay, so the elements up to index 1, they are forming a subsequence, a subsequence whose length is equal to 2, whose length is equal to 2. That is the meaning here. Okay, that means from this array, from this array, okay, so all the elements up to index 1, up to index 1 means index 0 and index 1, they are forming a subsequence whose length is equal to 2 here. That is the meaning of this one. Okay, so then what I can do is then I can take the next element. Okay, so 4 I can take here, 4 I can take here. Okay, so then check out whether up to this 1, 2, and 4, 1, 2, and 4. Okay, so are they forming a uh, increasing sequence? Are they forming an increasing sequence? Okay, so yes, they are forming an increasing sequence here. Okay, so then the length of this increasing sequence we will store here. Okay, so at index 2 here. Okay, so that we will store here. Okay, then similarly you check with the next element. Okay, so then 1, 2, 4, 3. Are they forming an increasing sequence? No, they are not forming an increasing sequence. Okay, so this you can obtain like this 1, 2 already formed an increasing sequence of length 2. When added with 4, it is forming an increasing sequence of length 3 here. That will store here. Okay, but 1, 2, 4, 3, it is not forming an increasing sequence here. Okay, like this with 1 we have tested here. Now you can test with 2 here. Okay, so 2 followed by remaining elements. Okay, so what are the remaining elements? 1, 4 and 3. Okay, so 2, 1 forming an increasing sequence? No. 2 and 4 forming an increasing sequence? Yes, they are forming an increasing sequence. Okay, so with index, okay, so with length 2 here. Okay, but already see here 4 is at index 2, no, so it has formed an index with length 3. Okay, so whichever maximum that we will store in this array, whichever is maximum that we will store in this array. Okay, so similarly 2, 3 forming an index. Yes, it is forming an index with length 3. Okay, so 3 is at index 3. So then previously only 3 was forming a subsequence. Okay, so 3 combined with 2 forming a subsequence, increasing subsequence. That's why its value increases to 2. Okay, so like this we'll go with the next element, that is 4. Okay, so next element 4. Then the remaining elements in this. Okay, so are like 3 we will check here. Okay, so 4 and 3, are they forming an increasing subsequence? No, they are not forming an increasing subsequence here. Got it? Okay, so then once you have calculated for all the elements, okay, so finding the uh, subsequences and storing their lengths in this uh, array called as LIS. Okay, so then if you return the maximum from this array, so what is the maximum from this array? So 3 is the maximum from this array. 3 is the maximum from this array. Okay, so that 3 indicates that the length of the increasing subsequence from this array will have a length called as a 3. Okay, so what are those? 1, 2, 4 is one such increasing subsequence. 1, 2, 3 is another such a increasing subsequence. Got it? So this is how we solve the uh, problem. DP approach. Okay, so that means if you want to draw the solution clearly. Okay, so for example, what we can do is we can take each element, as I said, this is 4. Okay, so this is 3. So each element, this element is one is at index 0, this is at index 1, at index 2 and at index 3 here. Okay, so each element and the length of this will be 1 here, length of this will be 1 here. Okay, so then you can start combining this with element 2 or with element 3 with element 4. This is how we do in brute force approach. Yes or no? In brute force approach, we will apply this kind of a logic here. Okay, so if you apply this kind of logic, 1 will combine with 2 3 4 2 3 4. Okay, so then 1 and 2 here will get 1 and 2 increasing subsequence. Okay, so then this index, okay, so 1 combined with 4, so you will get 1 4. This is one subsequence. Okay, so then you will get one such a subsequence 1 3. All of them have length 2 here. All of them will have length 2 in this case. Okay, so then index 2. Okay, so you can combine this with either 3 or index 3 or index 4. Okay, so when you combine 1 2 with index uh, 0. Okay, so this is 1, no? This is index 1, this is 2. Okay, either 2 or 3 you can combine here. So with the 3 element 3, if you combine, you will get 1 2 4 here. With the 3, if you combine 1 2 3, you will get here, like this. Okay, so this will have uh, length 3, increasing sequence 3. Okay, so then 2 you can combine with the index 3. Okay, so up to index 2 elements, then the remaining element is 3, you can combine with this. Okay, so it is 1 2 4 3. Okay, but this is not forming an increasing sequence. Okay, so like this, if you go on calculating, okay, so at each level the count will be increasing here. That means the number of times you are calculating will increase like this: 1 plus 2 plus 3. Okay, so then it's 4 plus 8, like this. The number of times you calculate increases. Okay, so it is not just like the complexity of this will be order of 2 to the power n. Okay, but whereas in DP the approach, okay, so you need to traverse this array, and for each element you need to check with the other elements. Okay, so one loop for traversing the array, then other loop only for matching whether is increasing subsequence found or not. Two loops we use. Okay, so this is order of n square. Order of n square is better compared to order of 2 to the power of n here. So let us implement this in the form of a code here. Okay, so we will define the function. What is the function name given in this? Okay, so it is just like a some increasing sequence. Okay, so we define the function called as a length of a increasing sequence. Okay, so length of a something like increasing. We'll define some name sequence. Okay, so I just given the name called as a sequence. Okay, so for this what you need to do, you have the array called as a nums as argument. Okay, so you calculate the length of the array here and store in a n. So length of nums you calculate. Okay, so then what we do is we create an array. Tabulation method, we use an array. Okay, so initially we'll store all ones. This array, this length of this array should be equal to the length of nums here. Okay, so this lis should be equal to length of nums here. So 1 multiplied with n, the meaning is store all ones in this array. Okay, so like this it stores all ones in the array, as I said. Okay, so the minimum length is 1. Initially we are storing each element forms the minimum length. Okay, so the element itself is a subsequence with length 1. That is what we can do. Okay, now you repeat the loop for each element in the array. So for I in a range, for I in range. Okay, so starting from, because first element you should start counting, forming a pair with the second element onwards. So index 1 up to go to n here. Okay, so that means I value will be generated like 1 2 3 in our example. If array is of length 4, okay, so if you consider this array, then it generates the I values starting from 1 2 and 3. These three values will be generated. Okay, so now what we do is we'll compare. Okay, so we will compare uh, with the previous elements. Okay, so the index 1 element will compare with the previous elements, index 2 element will compare with the previous elements, index 3 will compare with the previous elements. Okay, whether they are forming an increasing subsequence. Okay, because how do you know that it is increasing subsequence? If you are at the right side elements and if you compare with the previous elements. Okay, if you compare with the previous elements, if this element is greater than this. Okay, that means the right side element is greater than the left side element. Okay, assume this is left side and this is right side. Okay, so if it is right side element is greater than the left side element, then you can say that it is an increasing sequence. It is called the increasing sequence. Okay, so that's how we always compare this with the previous elements. Okay, so compare with the previous values, just or previous elements in nums. Okay, so for this, what you need to do, you need to go up to I minus 1 position. Okay, so for that, you need to run another loop for j in range. Okay, so range up to I minus 1 position, it should stop, means you should give the value as I only. Okay, so starting from 0 to up to I minus 1 position. That means range of I means it stops at I minus 1 only. Okay. So for j in a range, now you compare here. Okay. So you need to do this testing here. Okay. So that means if nums of I value. Okay. So this I indicates the outer loop. Okay, so I indicates right side elements. Okay, so j indicates left side elements. Okay, so if nums of I is greater than nums of j, if nums of I is greater than nums of j, that means if right side element is greater than the left side elements, that means it is forming an increasing subsequence. Okay, so then you update the subsequence value here. Okay, so lis of lis of I is equal to the maximum. You find out the maximum, because if it is already maximum, then no need to change, already it has formed a maximum. Okay, so maximum of a previous value in lis of I value. Okay, so then since it is j is changing the increasing sequence length here. Okay, so then what you need to do, previous lis value at j plus 1, you add a 1 to this one. Okay, because this right side value now forming a sequence, increasing sequence with left side value, that means the length is increasing, already it has a length 1. Okay, so now you need to add this element, so that's why we are doing this plus 1 here. Okay, so plus 1, now whichever is maximum among these two, that value will be returned here. Okay, so like this it repeats for the code, it repeats for the code for entire array. This repeats. Now let us work out this on our array. Okay, so our array nums is like 1, 2, 4, 3. You will understand. Okay, so then your lis initially is with all ones. Okay, 1, 1, 1, 1 stored here, 0, 1, 2, 3. So what does this lis indicate? Lis is a array or is a table which stores okay, so the length of a longest increasing sequence at index I, at that index I, for example here. Okay, so this index 2 element in this lis indicates that it is the length of the longest increasing subsequence ending at index 2. That means starting from 0 up to 2. Okay, so if it is forming a longest increasing subsequence, then that length up to this 2 we will store in this lis. Okay, so that we will use here in this array we will store. Correct. Okay, so now initially it is 1. Now let us work out for this. Okay, so I values I am taking here, so I values will be generated like 1, 2, 3 will be generated. Okay, so for j in range I, first I am taking the I value as a 1 here. So range 1 means it stops at 0. So that means it generates the j value as a 0. Okay, so that means what we are doing, this is our nums array. Okay, so I draw the nums array here. This is our nums array. So it contains the elements like 1, 2, 4, 3. Okay, 0, 1, 2, 3. Now j value is 1. That means, sorry, I value is 1. That means I am checking whether 2 forms a increasing sequence with the previous elements or not. Okay, so what are the previous elements? We have previous element only this one. Okay, so that is what I am checking here. Now j value is 0 here. Okay, so now I am checking these two elements, whether these two elements forms an increasing sequence or not. I am checking. That is what. Got it. So now see here. So if nums of I value is 1. Okay. So nums of I is 2. 2 greater than nums of 0. 2 greater than 1. Yes. Okay. So that means 1, 2, they are forming an increasing sequence. So then what we do is we'll update this. That means up to previously only at index 2, the individual element with length 1, it is the only longest increasing subsequence. Now with the previous element, it has formed a longest increasing subsequence. So that's why we need to update its length here. Okay. So this value we need to update here because it is forming a longest increasing subsequence. So that is what we are doing. See, LIS of index I. Okay, so I value means for 2 is forming a longest subsequence. No? So that's what we are doing. LIS of I value is 1. So LIS of 1 is max of okay. So how we calculate? Just see here. It is nothing but max of LIS of I. So previous count value. Okay, then LIS of j plus 1. Okay, so that means the previous element already it might have forming an increasing subsequence with its previous elements. Okay, so that length is already available here. That length is already available in this array. Okay, so that value we are taking. Now it is forming increasing with by adding this element 2 here. Okay, that means one more element is added to that now. So that is 1 plus 1. One is previously forming a one is previously forming an increasing sequence with length 1. Okay, now this one with 2 forming an increasing sequence. That means one more element added. No, so that's why we are increasing its count value as a plus 1 here. 1 plus 1. So whichever is maximum here 2. Okay, so that 2 we will store in this one. That means now up to index 2 we have an increasing subsequence of length 2. What is that increasing subsequence means? 1, 2 is the increasing subsequence. Got it? Okay. So then for I value 2, we'll take I value 2 here. Okay. So index at index 2, we will consider here. Okay. So then j in range 2, that means j value will be 0 and 1. Okay. So j value will be 0 and 1. Okay. So I value 2 means for which element we are checking? Now we are checking whether this element 4 forms an increasing subsequence with the previous elements or not. Okay, so we will check one by one. First, we'll take j value as a 2. That means we will check whether 4 and this 1 forms an increasing sequence or not. Okay, so I am comparing here. Nums of 2, I value is 2 here. This is my I value. Okay, so 2 greater than nums of 0, 4 greater than 1. Yes. Okay, so that means I am taking a, now see here, max of okay, so max of previous LIS of I. That means previously 4 individually it was forming. Okay, so what is its value? 2 here. Sorry, what is its value? 1 comma. Okay, so then with 1 it is forming an increasing subsequence. Okay, so LIS of j value means this one. Okay, 0. Okay, so in LIS 1 individually it is forming sequence plus 1 here. So greater value is 2. That's why we store 2 here. Okay, so that means 1 and 4 are forming a 1 comma 4 is forming one increasing subsequence with length value 2 here. Okay, right? Then j value 1, j value 1, it repeats for j value 1 here. Okay, so then I'll check whether 4, okay, so it'll form an increasing subsequence up to index 1. Up to index 1 it forms a subsequence or not. This is what I check here. Okay, so then it checks nums of I. Nums of I is 4. 4 greater than 2. 4 greater than 2, yes. Okay, so then I am updating this lis value here. Okay, so count value I am updating. It is nothing but max of lis of I here. So what is lis of I here? That means 2 it is. Okay, so what does it mean when this condition is true? That means 4 with up to index 1 it is forming an increasing subsequence. What is the previous increasing subsequence up to index 1 here? 1 2 is the previous index, previous increasing subsequence. Okay, now with 1 2 4 added, now it is forming another increasing subsequence. This is the meaning here. Okay, it is not with just 2 comma 4. No, it is not a 2 comma 4. Up to 2, up to 2, see here, up to 2 already lis of I value is there. Okay, so it is 2, I value is 2 comma. Okay, so 4 formed an increasing sequence with 1, this 2 here. Okay, now if you consider lis of j here, lis of j value, what is j value? 1 here. Okay, so lis of 1 value is 2. The meaning is up to index 1, up to index 1 there is an increasing sequence with length 2. Okay, so that 2 we will take, then we'll add plus 1 here. So greater 1 is 3, so then we'll update maximum with maximum value. Now this becomes 3. Okay, so now this is the longest increasing subsequence with length 3 it is forming. Okay, so then it checks for a I value 3 here. Okay, so that means whether this 3 will form an increasing subsequence with the previous elements or not. This is what we will check here. Okay, we'll start checking with index 0 up to index 1 up to index 2. Okay, so whether it forms, if it forms, then we'll update its count value in a lis array. Okay, so we'll start checking here. Okay, so I value is now 3 here. I value is now 3. This is my I value. Then j values will be 0 1 and 2. J values will be 0 1 and 2. Okay, right? So we'll start with the first j value here. Okay, so we'll start with the first j value 0 here. Okay, then it compares nums of 3 greater than nums of 0. Nums of 3 means 3, 3 greater than 1, yes. Okay, so that means 1 3 is forming an increasing subsequence. So previously 3 individually it is a value with 1 1, even now it is forming with length 2. So that means we'll update this value. When you update this value, this becomes a 2 here. Okay, so then j value becomes a 1 here. Okay, so then it checks nums of 3 greater than nums of 1. So 3 greater than 2, yes. 3 greater than 2, yes. Okay, so then we update this lis value here. Okay, so up to 2 there is one increasing sequence 1 2. When combined with 3, now it forms lis with length 3 here. 1 2 3 will be formed here. Okay, so that's why when you update this, now you can see here max value is lis of I, lis of 3 value is 2 here, comma, up to 2 here. Okay, so lis of j value is 1. So up to, see here, index 1 there is lis with length 2 here, 2. Now add 1 here, lis j plus 1, 2 plus 1, so value is 3. That means we update this with 3. Okay, so then next I value, j value becomes 2 here. Okay, so then it checks nums of 3 greater than nums of 4. Nums of 3 greater than nums of 4, no. Okay, so that means up to nums of 2 we have an increasing subsequence 1 2 4. When added with 3, okay, so this is not forming an increasing sequence. Okay, so that's why this fails here. Okay, so no update. That's it, the two loops completes here. Okay, now this is the array we got here. Okay, so whatever is maximum that you return here. So when you return max of lis that prints the value. That's it. Okay, so this is how we use dynamic programming tabulation technique. Okay, so this array utilization you should understand and you should know how to use this array. Okay, so based on your problem statement. Okay, so what values, kind of values you need to store in this table. Okay, so that if you can understand, then you can easily implement. Just it is 4 5 lines of code, just you can see here. Okay, so let us implement this in lead code. Okay, let us see whether all our test cases will be passed or not. Quickly we'll type this code since it is only 4 lines of code. Okay, so let me open the browser. So we will type the code inside the browser because everything is already given here. Okay, so let me increase the size of this. Now if this is increased, the screen. Okay, I'm adjusting the screen so that uh, you can see the code that is typed. Right, so the screen, let me adjust the screen. Yeah, hope you can see the screen. Yeah, so let me type the code. Okay, so the very first thing is we need to calculate a length of our nums array. length of nums I'm calculating. Okay, so then we'll define the table, LIS table. Okay, so with all ones stored here multiplied with the n here. Okay, so then what we do? So we will use a loop here. So for I in a range of n. Okay, so inside that we'll use a loop for j in a range of I. Okay, but here it should be one. It should start from a one onwards. We said no. So 1 to n. Okay, so then j should start from uh, I up to I. Range should be up to I here. Okay, so then we'll compare here. If nums of I. Okay, so if it is greater than nums of j. Okay, so then what we do is we'll update here lis of I is equal to max of lis of I, then comma previous lis of j value plus 1, because it is adding one extra element now. Okay, so that's it. Then we will return from coming out from the loop, we will return the max value of lis of lis. That's it. Max value from the lis we will return. Okay. So let us run the code first. Whether, yeah. So the test results are accepted here. Just you can see here. Case 1, case 2, case 3 all are accepted. Test cases. This is case 1. This is case 3. Test case 3 you can see here. Okay. So these kind of test cases you need to uh, devise yourself when you all numbers, if all the numbers are of same type. Okay, so what could be the increasing longest increasing subsequence? Only one element, 7 is the only element. Okay, so that's why the output should be 1. Output should be 1. Okay, so these kind of test cases you should identify yourself for your problems, which you may write in Infosys examination. Okay, so now let us submit this code and we will see whether private test cases will it pass or not. Okay, so now you can see accepted here. Runtime is given. Okay, so in green it is given accepted. 56 by 56 test cases it has passed. Okay, so all the test cases it has cleared. This is how you should perform in your examination. Got it? Okay, so try to implement this tabulation technique. Okay, so with some other problems like longest common subsequence, longest increasing subsequence with some other criteria. Okay, so common longest prefix sum. These kind of problems, if you work out, it would be helpful to you in the examination. So you will be mastering the technique called tabulation. So if you have any more doubts, I can take up your doubts. So friends, if you found this video helpful, so please like the video share this video among your friends, and also subscribe to my channel if you are new to the channel, and also click on the bell icon for more updates. So thank you one and all.